Hi everyone and welcome to this new video in which I continue my Windows Privilege Escalation series. The topic of this video will be scheduled task. We will introduce by discussing what are scheduled tasks, then we will see some commands that allows us to enumerate the scheduled task, how we can create and delete a scheduled task, and a simple example of exploitation of a scheduled task. As always, I hope the video is enjoyable, I hope you get something out of it. If you do, subscribe to the channel, share this video and this channel with like-minded people to help me grow, and that's it, enjoy the video. So let's start with a simple question. What are scheduled tasks? And here the name helps us a lot. Why? Because scheduled tasks are Windows computer programs or scripts that are executed automatically based on a specific schedule or trigger condition. Think cron job in the context of Linux. So in Linux we have cron jobs. Now in Windows we have services, which we discussed in previous video, and we also have scheduled task. While services are like daemons in the Linux context, scheduled tasks are like cron job in the Linux context. However, in Windows they're a little bit more complex because they can be executed based on a specific time schedule or also based on specific trigger conditions. So they are managed by the task scheduler service and they can be used for various types of tasks such as backup operations, system maintenance, custom scripts that need to be executed maybe to set up a development pipeline or environment. So anytime we have something that needs to be executed either on a fixed schedule base or on specific conditions, we can use scheduled task for that purpose. And as always, when we have a system that is designed to execute arbitrary code, because by design the scheduled task can be any sort of executable, so Windows executable, or any sort of script, so BET or PowerShell script. Anytime we have a system that executes arbitrary code, we must be really careful into how we use such system. So in this case, we must be careful in who has access to it, so who has access to the various scheduled tasks, how are they configured, what they execute, and things of the sort, because this is like a very significant surface attack if it's poorly configured. And of course, this note really applies to every system that executes arbitrary code. It could be Windows services, it can be Windows scheduled task. Anytime we have arbitrary code, this could be a problem. Now, I'm not going into full detail on the scheduled task data because it's very complex, but essentially, scheduled tasks contain different kinds of data, and these are way more complex than simple services. So here I've categorized data into these different sections: general information, triggers, actions, conditions, settings, security settings, and last run execution information. So in the general information section, we start out with some basic information about the task, such as the name, the path, the description, if the task is enabled or not, and the author of the task. Notice that the path with respect to the scheduled task does not refer to the file system directly, but it refers to this task schedule library. So it is a different library. You can think of it as a different file system on the system, and essentially when you want to specify a task, you must combine the path with the name. So for task, the identifier path plus name has to be unique. This means that task with the same name can exist in different folders, so with a different value for path, and in the same folder, task with the same name cannot exist. Now, what does it mean? It means, for example, that we might have path, we will see some practical example, with a simple slash. So this defines a specific namespace where task can be defined. And then I can have within this path, I can have different name. I can have task 1, I can have task 2, and things of the sort. And then the full name of the path, the full path for the task is gonna be /task1 or /task2. Now the idea is that since I have this concept of path, this does not refer directly to the file system, it refers to another file system, to the task scheduler library. And this is a useful abstraction to have, because for example, we can define for a different path, let's say I can put /custom, I can define a task with the name task1. So I can repeat the same name for the task as long as I am in different folders. And so we have this /task1 and we have /custom /task1. And these are going to define different tasks. So depending on the path, you're going to have different tasks. Within the same folder though, we must have unique task names. So within the same folder, I cannot define the two-time task1. It has to be unique. And when I want to interact with the task scheduler to say, for example, start this task or stop this task or delete this task and whatever, to fully specify the task, I'm going to use path plus name. So I'm going to use the full description. Another thing of interest is the triggers. Now the triggers specify the condition under which the task will run. And there are different types of triggers. We can have time-based triggers, which are the most common, and these are like actually mapped to the cron job in Linux, and we will see an example of a time-based trigger later on. We can also have different type of triggers, so not only time-based, we can have event-based triggers, which are triggered by system events, like the user logs on, or the system starts up, or an event in the event log. So like any sort of event that can be captured, I can define a trigger on it so that when that event is captured by the task scheduler, it's gonna activate this specific task. So each trigger contains the following information: the start and end date, so start time and end time, which means when does the task start and when does the task end, and then the recurrence interval. And of course, this is mostly for time-based. For event-based, you can say, okay, trigger this task every 30 minutes, so that when 30 minutes have passed, it's gonna trigger again. If the same event happens 2 times in a single window of 30 minutes, it's just gonna execute it once. That's the idea. Then we have the actions. So this is gonna specify the action that has to be done when the trigger is satisfied. So when the trigger starts, when the task is triggered, what's gonna happen? So here we have typically an executable with some arguments and maybe a working directory, so that we're gonna execute, for example, a PowerShell script within a given working directory with some specific arguments. Then the conditions, so like network, power, idle time, we will not really care about that because that is too much detail for our purposes. And then, of course, we can specify more general settings, like allow a task to be run on demand, restart on failure, things of the sort. Once again, too much detail, we will not really care about that. And then there is some security settings, which of course are interesting to us, which for example defines, okay, run with this particular user, run with this principal, run under these privileges. So those are really important. And then for each task, we have information on the last runtime, the next runtime, and the last run result or the status for error details. So essentially when we run a task, it's going to say, look, last time I ran on the 10 a.m., I'm going to run next time on the 11 a.m. if the task was scheduled with a time-based schedule for every hour. Now, tasks can be a really complex surface attack because they're not really easy to enumerate. So let's see some commands to deal with tasks. This is a PowerShell command that allows us to list out all the scheduled tasks that our user has access to. So we can do with the get-scheduled task. So we open a shell, as always here. I do get scheduled task, and here I have the list of tasks. Notice that in this list we have 3 main information essentially, which is the task path, the task name, and the state. So notice this, in the /task path we have a bunch of tasks regarding to OneDrive. Then we have the taskpath.net framework with all the tasks related to the .NET framework, and so on and so forth. This is the idea, this is the concept that we talked about previously. And while the getScheduledTask works in PowerShell, we can have like an equivalent in CMD, which is SCH tasks. So essentially we can just open a command prompt, we can just do SCS query, and we get all the different information depending on the folders. So in this case, they are already organized by folders. In this case, we have a more like the folder is repeated in case. Now let's say that we want to list out all the tasks, but only those in a specific folder. So here we can use typical PowerShell syntax to filter out. So here we're getting all the tasks, but here we are filtering on the objects where the task path property is equal, for example, to Microsoft Windows shell. So we execute this and we're gonna get only the tasks that live in that specific path. So let's copy it again. I'm gonna copy it here, execute it, and here I get these different tasks: create object task, family safety monitor, family safety refresh task, update user picture task, all of these things that run on this specific path. Now, if I want to list out some more information with respect to a specific task, I can do this. I can do get schedule task, task name. And so, for example, here we can execute this get schedule task with the task name create object task. And here we get the information. It's like we wait a bit. So we execute this. And we get information regarding two different tasks. One that lives in the task path Microsoft Windows Shell, and the other that lives in the task path Microsoft Windows Cloud Experience Host. If we want to be more specific, of course, we have to introduce a new filter here, task path, essentially. And in this task path, we have to put the path like this. So like this, and then we go here, and then here we put this. And we're gonna get the details on this specific task and not the other. As you can see here, some information are last runtime, last task result, next runtime, number of missed runs, the name, the path, and the computer name, which is not set in this case, so more detailed information. Another way to obtain information is by just formatting all the properties with this format list. So here we have a task name, and here we have all the properties, and notice that the actions, the triggers, and the instance properties are complex objects themselves, which can also be expanded, essentially. So here we also have the principal, and this is gonna define the user the principal is gonna be used to execute this task. So for defining the security context to run. So that's the idea. Now, for example, let's say that we want to extract the binary path of a given task. So here we can just zoom in to the actions component of the task. So we do get schedule task, we put the name, and then we put .actions. So let's copy it. I'm gonna get this. And so here we get execute windir system32 and then the name of the task, which in this case is a simple executable with the arguments standby. So this is how we move from the task name to the actual binary that is executed. And if we want to do this for every task in the system, we can just do a simple loop for each object, and we can simply extract the actions object, the action property in a way. So we do this and we extract all the executable. Once again, depending on the permissions of this executable, you could maybe be able to overwrite it with a malicious executable. And if the task is periodic, is scheduled to run every minute or something, there you go, you have code execution with your arbitrary code. So that could be a path. And to get to the actual executable, you can use these commands. Of course, you can customize it depending on your need. Finally, let's say that you want to export the configuration as an XML file because it is easier to read, maybe, also for automatic enumeration processes. So you can do export schedule task, you can put it here, you put the task name, and here you have essentially all the details of the task. And in this XML, you will find information on the actions to execute, on the context of execution, which in this case is local system, the command to be executed, the arguments, the triggers, which specify the condition, the principal, which is once again local system, and all other details. So it could be an interesting thing to extract. Now, to get more familiar with schedule task, the idea is let's create and delete a simple schedule task and see it in action. So let's create a simple task that runs when the user logins into the system. So we're gonna have a trigger, and the trigger is gonna be @logon. So to define this new task, we do it with essentially 3 different commands. In the first one, we are defining the action. And in this case, the action is just to execute the notepad.exe executable. So it is just a simple notepad instance. So we define this. We need, of course, a privilege shell to create a new schedule task. So we're gonna execute a privilege shell here. So first we create the action object, and this is done. The second thing is that we're gonna define the trigger condition. In this case, we're gonna say new schedule task trigger @logon. So this specifies, okay, when the system logs on, you're gonna execute this code. So a simple trigger, and we define a trigger. and finally we can register the new task. Here we put the task name, here we put the action using the object that we created previously, same thing for the trigger, and finally the user that we're gonna use to execute this task, which is gonna be our QuickEmo user essentially. So in this case it's QuickEmo, actually let's see if it's correct, who am I? It's QuickEm H5DS, so QuickEm H5DS, perfect. So we're gonna register this task as the name my task. Notice here we did not put the task path, so it's gonna start from the root. So we're gonna execute this, of course not this, but this other. And here we have registered our task and the state is ready. So it is ready to be executed. Let's go and enumerate, for example, the details of this task. So in this case, the details is my task here. And I'm gonna get these details. So I'm gonna say, look, the last runtime was never essentially. And so to actually trigger it, what do we have to do? Well, we just have to log out and log in again. So we're gonna force a logout. I'm gonna do a sign out. We're gonna wait, then I'm going to log in. So here, essentially, I put the password. And now the task is gonna be executed because the trigger condition is gonna be met. So I'm logging into the system and then I'm gonna execute the task itself. And notice now that I have a notepad ready to be used. So this could also be useful for automation and things of the sort. So this is how we register a simple task. And then of course, let's say that now we want to delete it. Also, let's try to see if it now change the last run. So notice this last run at 18:11, which is like right now. And so that's the idea. So to delete it, what do? We simply do unregister schedule task with the name. So like this. And here we have it removed, not property simple task, because it is not simple task, but it is rather my task. So it is no longer there, essentially. In this case, the task path was here. So if we check information on this again, get schedule task info, it's not gonna find it because we have just unregistered, and so we have removed it from the data structure used by the task scheduler. And finally, let's see a simple example of exploitation. So for this exploitation, we're gonna define another simple task. This time, however, we're gonna execute the task every minute, starting from the moment we define the task until 1 year. So here the action is gonna be execute a PowerShell.exe with a specific argument, and the argument is gonna be a script on the file system. So the script is gonna be in C users QuickEmu task test1.ps1. So essentially, we are saying to the system, okay, every minute execute this script. So this is gonna be our action. So we do this action, new schedule task. Then we're gonna do the trigger. So the trigger is essentially once at get date, so we're gonna get the current date, and then the repetition interval is every minute. So new time span minutes 1, repetition duration for 1 year, so 365 days. So we're gonna define the trigger. So this is gonna be a time-based schedule task, so the schedule is gonna depend on the time. Then we're gonna define the principal, which is gonna be the user profile for security that's gonna execute the task, and this one is the system user, and it's gonna run with the highest level of privileges, so it is a very dangerous task to define in the first place, of course. And then we're gonna register the task. We put the simple task as the task name with the action, the trigger, and the principal. So we register the task, and now we have registered the task. So this is it. Now, what does the task do? In this case, the task is pretty simple, because if we go into the path, into this task, so C user QuickEmu task, this thing is just gonna, if I edit this PowerShell, it's just gonna execute a whoami, and it's gonna write this output into this file, test whoami.txt. So in this case, this whoami is gonna say NT authority system, because that's the user that is executing the task. For example, if I remove this, and I just wait for the next execution, which anyways, I can get this information by asking for the get schedule task info with the name simple task, and it's gonna say essentially, look, the next one is gonna be 1717, so we are gonna wait 1717 and it's gonna execute it again. At that point, a new file will be created. Now, let's talk a little bit why this can be dangerous. Well, of course, what's the problem here? The problem is on the configuration of this scheduled task. So the issue we need to understand is, wait, who can access this file? Because if other users can edit this file and they can introduce malicious PowerShell, then they're going to be able to execute malicious code with higher privileges every minute, which is not a good thing. So notice now the file has been created and it says on NT authority system, and essentially if I do get scheduled task, it's going to say, look, the last run was in 18-17-17, this one is 18-18-18. So that's the idea. And in these cases, a simple exploitation technique is just, okay, we understood that this file is executed by a scheduled task every, for example, minute with higher privileges. Okay, let's insert some malicious code. Pretty simple. And here, for example, I change this, I put the shell, and I wait for the next execution. So here, for example, it's going to say 40-40. I've noticed that typically it executes a little bit earlier than that, but that's the idea. So here we wait a bit and then we get our execution. Of course, in real system, this is not this simple. Why? Because in this case, we were the one who created the task. In real system, what the hard part is the enumeration part of scheduled task. If we had all the information, it would be easy to understand if the system was vulnerable, but the point is that we do not have all the information. And notice here we get the shell execution and it is around like 10 seconds before the task itself. I think it takes some seconds to execute, so it does it earlier. But that's the idea. We have our shell, and of course this shell is run as like the user system authority system, so higher privileges. And so we can do whatever with our shell. So as I was saying though, the problem is that it is not easy to enumerate the scheduled task. This is why scheduled task is an interesting attack surface, but it is not always doable to deal with it and to exploit it because it is not easy to enumerate. Specifically, if we if we try to search for this task on a normal shell here, we get no information. Why? Because this task is only available in higher privileges shell, for example in this one. So in this one I get the information, I get when it runs, I can get the executable, like for example if I say format list, if I say action, sorry, if I say action like this, so I'm gonna copy this, so not like this, but if I say this and here I say let's do simple task, I copy this and I execute it here, I get, of course, that this is a PowerShell file, but only in this privilege context. In a normal shell, I do not have access to this information. And if I try to search for this task in a non-privileged environment, I get an error, doesn't find the task. So ultimately, the exploitation of scheduled task is not that easy to do, because it is not easy to enumerate the scheduled task. This is why I suggest to keep in mind that they exist, but not focus on this path for simple certifications such as the OSCP certification. Try to maybe check if certain files are created, or maybe if you have other information like a history, PowerShell and things of the sort. So if you happen to see commands like the following, like new scheduled task principal, register scheduled task, and things of the sort, do try to understand if there is a scheduled task going on. Otherwise, focus on simpler things to enumerate first before going into the scheduled task enumeration. And these are some simple references taken from the Microsoft documentation. This is it for this video. We analyze the concept of scheduled task. We discuss what they are, how can we enumerate them, how can we create and delete them, and how we can exploit the main idea. And we also said that the hardest part of this is to enumerate, is to actually understand what is going on at the level of the system with respect to the scheduled task, because we do not have all the information with a low privilege shell. So I hope the video was enjoyable and you got something out of it. If you did, subscribe to the channel, share this video with like-minded people, and to the next video.